we are going to look at simple random sampling as highlighted by the red color there. Let's look at the simple random sampling. The first step is find the sample size. Yes, it's from the sample size table. Next is write the names of each individual in the population on separate slips of paper. This is a rather tedious job if the population size is large, but that's exactly the reason why we do this procedure for situations where the population size is manageable. The third step is place the names in a container or hat. Yes, that's what exactly we are going to try out here. The step after placing all the names of the population in this container is to pick up one. That's the next one. Yes, and you note which name is selected in the roster that you may have, and then put it back and keep picking up till the desired number is reached, and each time we must note the name that is selected. Well, we need to make sure that the selected slip is put back before putting the next one. Why is that so important? Yes, you guessed right. It is really for giving equal chance to be picked for the subsequent ones. This is very important. Every member of the population should get equal chance to be selected, remember? Yes. Now we are ready for the next sampling procedure, and this has to do with systematic random sampling. Systematic random sampling is a very simple procedure too. In this situation, we again begin with the sample size, and then we go to the next step of calculating the nth term. This is simply a number that we come up with by dividing the population size by the sample size. So if the population size is 1,000 and we saw from the sample size a particular sample size, you divide that 1,000 with that sample size and you come to the nth term. And that n is very, very important, because in the next step, third step, from the list of population, we select every nth name until the sample number is reached, till the end of the list. We keep doing that. Remember, if there is a decimal for the n, the small n, then it's always good to just remove the decimal and take the absolute value. Smaller the n, more sample may be arrived at, and it's always good to have more sample size than less, and you will know why, because there is a chance that somebody may not respond, or it's always good to have additional number in the sample size. Yes, now we go to the next random selection. This is using random numbers. This is simply a table with random numbers. I will explain this very simply. The procedure is first find the sample size. You know, it's again using the sample size table. The second, begin at the point on the random table. Okay, usually at the first point. Okay, perhaps we need to see the random table And let us go to the random table for you to understand what this is all about. Yeah, this is a kind of mind-boggling table. It's full of numbers. This table is produced by a special program in the computer, and these numbers are just spilled out randomly, and there's a program that can group these random numbers into different clusters of digits. In this particular table you can see 1, 2, 3, 4, 5 digits. 5 digits of clusters of random numbers. So you can begin right at the corner there. By the way, that many such pages can be produced for the purpose of using it for selection of the sample. Let's begin at the right, left side top, yes. And imagine that you found the sample size as 824. Imagine that. You select only the first 3 digits from each group, the first 3 digits. So 824 is the number we are looking for. Any number that is 824 or less will be selected. Now when you look at the very first number, it is the first 3 numbers is making up 837. Oh, that is too large. We need less than that. So let's look at the next column, the first number there, and we see 312 as the first 3 digits. So we will select 312. Okay, that number, mark it, and then in our roster of population, we'll go. Remember, this roster is supposed to be a numbered roster. We'll select the individual whose number is 312. So this individual is selected. Okay, now when you go down go horizontally, we'll find the next possible selection is of 9. So this would mean the 9th person in the population list will be selected. Okay, and the next one, 543. Oh, that's good, because the last number we need is 824, and 543 fits very well. All right, so we can go on like that, row by row, till we get 834 of them. By the way, this again may be quite tedious, but for reasonably a smaller size, this procedure is possible. Something like a size of, let's say, 120. Okay, that sample size would be easier to manage this table with than 824 or so. But I was just explaining how this table can be used for selecting the samples. We will go to the next procedure now. By the way, till the desired number is reached, we need to continue this. All right. So each time you find the sample, you will mark it on the population roster, and the very last one is marked off, which would mean the last of the sample size is reached. Then the procedure is complete.